Hi everyone, Peter here from Flow High Performance, and in this video, we will cover how to develop acceleration ability for athletes. First, let's break down the mechanics of acceleration sprinting. By looking at various mechanical variables, we can establish a better idea of how to best train acceleration. The first mechanical variable we will explore is ground contact time. This refers to how long the foot is in contact with the ground during each stride. This is important because an athlete can only apply force when the foot is in contact with the ground. This study explored the kinematics of high-level sprinters during maximal effort 50-meter sprints. As we can see here, the ground contact times over the first 5 to 6 steps were much longer than the latter portion of the sprint. Ground contact times during the acceleration portion of the sprint were around 0.13 to 0.18 seconds on average. So during acceleration, athletes have more time to apply force into the ground compared with max velocity sprinting. The next variable we will explore is range of motion during ground contact. Athletes generally strike the ground with the hips and knees at roughly 90 degrees of flexion during acceleration sprinting. So the hip and knee extensor muscles must produce force from around 90 degrees of flexion to full extension. We also see minimal ankle movement during acceleration sprinting. The ankle joint remains locked in a slightly dorsiflex position until the very end of the ground contact, where it then plantarflexes to provide additional propulsive forces. And the last mechanical variable we will explore is muscle actions. As we already discussed, the hip and knee extensors must produce force from around 90 degrees to full extension. Athletes strike the ground slightly behind the center of mass during acceleration sprinting. This means that muscle actions are primarily concentric in nature as there is minimal eccentric loading. Since the ankles don't move much during ground contact, they primarily work isometrically to maintain a stiff ankle joint. The stiffer the ankle can be held during ground contact, the more force that can be transferred into the ground from the hip and knee. Now we can explore how to train to improve acceleration performance. There are 5 primary training methods that athletes can use to improve acceleration performance. The first method is unloaded sprint training. This is obviously the most specific form of training and is the most important method. Athletes must perform unloaded sprints for any other training methods to have positive transfer to acceleration performance. When we want to emphasize acceleration performance, we want to use shorter distances of around 10 to 30 meters to focus on the start of the sprint. Sprints should use maximal intent and allow full recovery between efforts. This is because we need to sprint with maximal effort to improve performance, and submaximal rest will inhibit our ability to perform at 100%. The next most specific training method we can implement to enhance acceleration ability is resisted sprint training. Resisted sprints refer to any form of sprint training that involves running against some form of external resistance. There are many ways to perform resisted sprints, but I think the sled pull is generally the best exercise for most athletes. Resisted sprint training increases the force demands of sprinting, meaning that athletes must apply higher forces into the ground to propel themselves forward. Resisted sprints also teach the athlete to sprint with effective acceleration mechanics. In particular, resisted sprints encourage a forward lean of the torso and explosive extension behind the athlete's center of mass. Resisted sprints should use distances of around 10 to 30 meters and be performed with maximal intent and full recovery, just like unloaded sprints. The resistance used can be periodized over time for the best effect. Higher resistances can be used earlier in a preparation cycle to emphasize force output. Lower resistances can then be used later in the preparation cycle for maximum transfer to acceleration performance. Another training method that can enhance acceleration performance is power training. Power training refers to ballistic exercises using external loads. Ballistic exercises are those which involve no deceleration phase, such as jumping and throwing variations. Power training can enhance the ability to produce higher forces in short time frames. While power training doesn't use movement patterns that are specific to acceleration sprinting, we can still use power training to enhance the general ability to produce higher forces in shorter time frames. Power training can use different loads based on what we want to emphasize. Heavier loads should be used earlier in the preparation cycle to emphasize force output, while lighter loads should be used later in the preparation cycle to emphasize velocity. This will build a foundation of force output, which will potentiate the ability to produce forces in faster times. Another training method that can enhance acceleration performance is maximal strength training. This refers to using traditional compound lifts to maximize force production from the lower body. If we can produce more force from the legs, then athletes can allow this force to be used during acceleration sprinting. Athletes can use different strength exercises based on preference and training experience. Generally, I think the trap bar deadlift or the box squat are great exercises for athletes as they allow a heavy load to be moved with a standardized range of motion. Maximal strength training can be periodized by using higher rep ranges earlier in the preparation cycle and lower rep ranges later in the cycle. This will emphasize muscle hypertrophy initially and allow the highest force output later in the cycle. And the last training method that can have positive transfer to acceleration performance is isometric strength training. Isometric strength training refers to exerting maximal forces without any joint movement. Isometric strength training should be performed for the ankle joint, as this joint is required to maintain an isometric position during acceleration sprinting. It is important that the ankle doesn't collapse during each stride, otherwise the force produced from the hips and knees will not be maximally transferred into the ground to propel the athlete forward. Isometric strength training can be performed by pushing maximally against an immovable object. For example, an athlete could set up a barbell underneath pins in a squat rack and push up with the ball of their foot on a weight plate. Isometric strength training can be periodized by using longer duration holds of around 10 to 20 seconds earlier in the preparation period and shorter holds of around 3 to 5 seconds later in the cycle. Thanks for watching, and hopefully you got something out of this video. Remember to subscribe if you haven't already.